This is podcast 3.4 for chemistry, and we're still doing naming and writing ionic compounds, except this time we're going to add on one more thing and enter polyatomic ions. So you need to make sure that you have your laminated periodic table sitting in front of you, and you need to flip to the back side where you have the cations and the anions list. So, naming rules when we're talking with polyatomic ions. The first part is still the same. You're going to name the metal or the polyatomic ion. And polyatomic ions, those are your ions that are under the cations. The only one under the cations is ammonium. Everybody else under there is a metal. But then your anions list is where a lot of them are. So polyatomic, poly meaning more than one. We have a bunch of atoms kind of all stuck together. So you're going to see more than one capital letter with polyatomic ions. So for example, ammonium is NH4+. Carbonate is CO3 2-. So we're taking a bunch of atoms and we're making these molecules that stick together that we then put into ionic compounds. So you're going to name the metal or the polyatomic ion, don't change the name. If it's a transition metal, remember to use your Roman numerals like we talked about in the last podcast. And then the last part, you're going to name the nonmetal or the polyatomic ion. If it's a nonmetal, we still do that "-ide ending, but if it's a polyatomic ion, you're not going to change the name. So the simple rule is if you have a polyatomic ion, you don't change the name of it. You're going to keep it the same. So moving on to some practice, we're going to start by naming first, and we have a mixture of all three types that we've talked about so far. So LiCl. Li is lithium, and I don't need a Roman numeral with lithium because this is not a transition metal. Cl is just chlorine, it's not a polyatomic ion, so this is just lithium chloride. That's the simplest version that we've done of ionic compounds. Then we have Mg. Mg is magnesium, not a transition metal. I don't have to worry about doing Roman numerals. But then I have this thing here. My Q is I have more than one capital letter. So what you're going to do is you're going to go to the back of the periodic table. You're going to look under the anions list for NO3. And you're looking for whatever falls in parentheses. So with NO3, you're going to see that it's nitrate. And you need to be careful when you're looking up these names because there's nitrates and there's nitrites. There's sulfates and sulfites. They are very similar. They differ by their oxygens, so you need to pay attention and look very closely to what you're picking. So this is just magnesium nitrate. I didn't change its name. It just stays how it is. Ca is calcium. Calcium is not a transition metal, so I don't have to worry about Roman numeral. And then I go look up CO3 on the back under the anions list, and it is carbonate. So that's just calcium carbonate. Fe. Fe is a transition metal, so I'm going to have iron, something in Roman numeral with Roman numerals, and then I look up SO4. SO4 is sulfate. So sulfate has a -2 charge, and I do not have 4 sulfates. I still only have 1, because on your list you're going to see sulfate is SO4. So that 4 is not saying that you have 4 of them, it's part of what sulfate is. I only have 1 sulfate, so that's a -2 charge. That means that this iron must be a +2 to balance it out. So this is iron 2 sulfate. Aluminum is not a transition metal. I don't have to worry about Roman numerals. Sulfur is not a polyatomic, so I just changed the ending to "-ide. And the last one here is copper. Copper we know is a transition metal. I'm going to need a Roman numeral. And we have SO4 again, so sulfate. Again, sulfate, -2 charge, so this side must be a +2. I have 2 coppers. 2 times what is 2, and that would be a 1, so copper 1 sulfate. All right, the last way we're going to practice these is writing them from the names back to the formulas. So we have manganese. Be careful that you don't confuse manganese and magnesium. Manganese is a transition metal, which is why they gave us the Roman numeral telling us it is a +4. Chloride is just chlorine. What you can look for, and it works most of the time but not all the time, if it ends in IDE, it's most likely an element. So you know to go to the periodic table. You know you don't need to use that anions list. The one you need to watch out for, though, is hydroxide. Hydroxide does end in IDE, except it's not an element. It's not telling you hydrogen. That would be hydride. So hydroxide is the one where you need to watch out. But most of the time, if it ends in IDE, you know it's an element. So this is chlorine, and chlorine is a -1. So a +4 and a -1. I'm going to need 4 of these to balance it out. Manganese is Mn, and the chlorines, I need 4 of them. Ammonium. Ammonium is the only polyatomic ion with a positive charge. So that's a +1. If you looked it up under the cations list, you could find it there. It's the first one. Chloride again, chlorine is a -1. So +1, -1, they balance each other out. So NH4 is ammonium, Cl is chlorine. Rubidium. Rubidium is a +1. Hydroxide is a -1, and that's the one where we need to watch out for. That's in the the anions list. So this would just be RbOH. I just need one of those to balance each other out. Barium is a +2. Phosphate is a -3. So you've looked up phosphate under the anions list. It's a +3 or a -3. All right. Barium and phosphate, we're going to shoot for 6 to get those to cancel. So I'm going to end up needing 3 bariums and 2 phosphates. So I'm going to have Ba3, and then the phosphate is PO4. I need 2 of them, and that goes out here. You need to make sure you use parentheses if you need more than one of your polyatomic ions. So in this case, a lot of people would do this. They would go PO2 because they forget that that 4 makes the phosphate a phosphate. You need to have 4 oxygens on there. So this is not the correct way. Make sure you do parentheses and put however many you need on the outside. So again here we have copper with a 2 charge, phosphate again, so I'm going to go for 6. Copper, I'm going to need 3 of them. Phosphates, I'm going to need 2. Cesium is a +1. Sulfate is a -2. That's on your anions list. That's polyatomic ion. So I'm going to need 2 cesiums. So CS2SO4. You need to become really familiar with that list, that anions list on the back of your periodic table. We're going to use it a lot. You also need to make sure that you remember to use parentheses if you need more than one of your polyatomic ions.